Okay, so year 10s, just follow along with your one. If you've got any questions, just stick your hand up, but we'll see how we go. Now, I'm just going to actually enlarge my copy, so I did ask you all guys to come to the front, those who are sitting at the back, but we can get started. Okay, so I'm going to work on the tennis ball one. So this is the vertical motion. This is the ball that was dropped. All right. Now, so do that. All right. So for those who missed out, I'll just remind you, for those who forgot from last week, the alternating current that's in the power packs is 50 hertz. What that means is that ticket timer was stamping 50 times a second. So does anyone remember how we actually came and found the time between the dots? What did we do? Not too sure. That's right. We'll go through it again. All right, because this is important. This is how you set the time. So if the frequency, if it happens 50 times a second, the time between stamps is 1/50th of a second, or 0.02 seconds. That's important. That's the time between those dots. And because that's a consistent time, we can use the ticker tape as a way to represent motion. That's what we're going to do. All right, so I'm just going to show you what I did with my ticker tape. So the first one I've got here, you can see it on my screen, but that is the one for the rolling the ball across the table. So see what I've done? The focus isn't all that great, but you might be able to see there's actually 5 dots between the vertical lines I've drawn. Does everyone see that? Oh, if you can't see the dots they're quite faint, trust me on that. There's 5 dots. So if each dot, the space between each dot is 0.2 seconds, what would I do to work out the time between these? Want to have a guess? Dre, what do you reckon? If I've got 5 dots, 0.02 seconds, times by 5? Yep, sounds good to me. All right, so for that one, I might even just put that on here for now. All right, so if I times by 5, actually, sorry, let's bring up this. If I times by 5, so for the first one, times by 5 equals 0.1 seconds. All right, so I'm going to put that into here, just as a reminder for later. So you can type that in as well, just 0.1. And that's going to keep increasing to 0.2. Whoops, that was for the wrong one. Let's go across the other one. That's for this one. I'll show you the other one. Okay, so let's delete that one. Okay, now I'll show you the other ticker tape. The other ticker tape was for the vertical motion. Let's find the start of that one. Okay. So the vertical motion ticker tape, not that. The vertical motion ticker tape looks something like this. And you see as I go, the gaps between each of the dots is getting much larger. But you notice I've drawn vertical marks on every dot. Okay, that's what I actually suggested you did with your data. But I wasn't quite happy enough with that because you might see that, okay, let's start from the start again. I'll show you what I mean. All right, as we go from the start, we go, the space between the first 2 dots is 2.25, 3.05, 3.3, 3.5. It is increasing, and quite significantly. Then 4.55, 3.55, 4.9, 4.1. You see it's jumping back and forth a bit, but it's a general theme that is increasing. So what I decided to do, the numbers I actually have on the bottom, that I see I wrote there, 5.3, 6.8, and so on. Those are for the distance between 2 adjacent dots. So I decided to go with that scale for my data. If you're working with your own data, you can do it the way you like. If you do it for every one space, it's 0.02 seconds. If I do it for 2 times 0.02 seconds is 0.04. Okay, so let's put that into here. So we're mostly working with the tennis ball. But what you type into here, so get back to your tennis ball. I'll just focus in on that one. 0.04. Okay. Now, so that's going to be our time scale. Every row is going to increase by 0.04. So the next one, 0.08. Now, to save you having to type out all of those, okay, when you write those two in here, what you can do, it's a little trick. So the great things about spreadsheets is while we're doing a lot of math, the spreadsheet can do a lot of that math for us, and I'll show you how. So in many cases, it can interpret what you're doing with every adjacent row. I'm going to click, you see this little box on here at the bottom? If you click on this, I'm going to drag that down to where my data ends, which is there. Okay. And what it's gone and done is it's interpreted that each row is increasing by 0.04. So it's gone and worked out the rest of those for me. So 0.12, 0.16, 0.2. Okay. Does anyone want me to do that again? No? Happy? Okay. Now, so the main goals, what we want to do is we want to get a velocity time graph and a displacement time graph. The numbers here are the change of displacement. That's what the little delta symbol means, change of. That's what I actually had on the ticker tape between two adjacent spaces, 5.3, 6.8, 8.1. That was pretty nice and reduced the random error. You don't have the numbers jumping around so much, but it only means we have 6 data points, but that will do for what we're doing here. Okay, so first thing we need to do, all right, we're going to convert this to meters. So I've just gone and copied over this delta S. Okay, all right, now, so remembering, how do we convert from centimeters to meters? So centimeter to a meter. So we want to work with meters, divide by 100. Okay, now, instead of going through and doing all those calculations, we're just going to do one calculation. We're going to make the spreadsheet do it for us and then repeat that command. So I'll show you the trick. First thing you do is type in equal sign, and then that will tell the spreadsheet it needs to do an operation. Okay. Then we're going to act on this value here. So we're going to click on the centimeters here, 5.3, click on that. You see now it says equals J3. Then we're going to go slash 100. Okay, you see what that's done? It's gone and divided by 100. Is everyone happy enough with that? Okay. Click and drag? If not, we can come back to the time. The time's not important until later on anyway. All right, but this one's important, so I'll just do that again. Okay, so to do the element where you convert into meters, equals 5.3 divided by 100. So use the forward slash for 100. Okay. Then what you can do, go back to that, and again, you can actually click on the bottom square here, and this will carry out the same operation for each row. All right, so you can see all those numbers have been divided by 100. Okay, so you can see here, if you look at the element up at the top, J5 divided by 100, J6 divided by 100, and so on. So it's gone and carried out that operation. That's handy. All right, so we've actually got enough here to do our first graph, but I'm actually going to work on the on this first. Okay. So what I'm going to do with this one is what I'll do is I will actually work out the displacement. All right, and so what I had in the other column, these two, they're the changes of displacement. So that's what happens. That's the space between each adjacent. So each adjacent 2 dots. In this case, I'm actually going to add up all of those. So this is going to keep adding. So the command I'll put into here. So the first one will start with 0. This one here, I'm going to go equals. Okay. I'm going to click on, so I don't need to do the 1 centimeters. I can if I want to, but it's probably better if I just work in meters. Click on this one. Oops. Sorry, wrong way. Okay. Let's try that again. All right, equals. Now, what I want it to do is it wanted to add the last thing it has in the row above. So right now that's 0, but you see this will become important when I click and drag this. All right. So equals. Click on the one above, the 0, then plus this one here. So what's it doing is it's adding these two numbers. But as I go down the row, it's going to add this onto what it had previously. All right. So the first one. Okay. So the first one is all right. It's moved 0.053 meters. But if I click and drag, I'll click and drag up to the row below. All right. So what it's done now is it keeps adding all these distances. So this is how far it is actually from its origin, whereas this is how far it's moved in each separate interval of time. Okay. All right. Some of you might be a bit behind with this, but just help each other out. All right. I'll come by and help other people who are a bit behind in a minute anyway. But I'm going to go through the graphs now. All right. So to do the graphs, all right, we're going to highlight. The first one we're going to do is this is the velocity time graph. Okay, we're going to highlight this column and press Control and highlight this second column as well. So highlight the time data and highlight the displacement meters data. So you can highlight that just by clicking and dragging, then press Control and click and drag that one too. This seems to be the quickest way I've found to actually do the graphs. Okay, now to get your graph, that's you. We're going to go into Insert. Okay. Nope, that's how you do in Excel. Actually, no, I think I'm going to have to make this a bit. I can't get the rest of the menu up. All right, sorry, I have to shrink this down. There we go. Okay, there we go. Insert chart. So I couldn't see the rest of the menu screen. All right, so for those who can't see at the back, well, just a make do. Go to Insert, highlight those two things as I suggested. Go to Insert Chart, and the chart you want is a. So go to Chart Types. We want a scatter plot. So this one here, scatter with a bunch of dots. Okay. All right, scatter, bunch of dots. Okay, go down. Again, I have to shrink this down again because I can't see the bottom of the menu. There we go. All right. So scatter and then insert. All right, and what we have here, we've got an extra data point for some reason. I'm sure that's, oh no, I know what that's for. You can get rid of that. All right, so this is our velocity time graph. This is, we haven't described what this is. That's why there's extra dot there. It's actually not data. It's just, it's there for a title. Okay, so if you do it that way, the way I've described, you have the, oops, sorry, this is actually the change of displacement graph. I've missed one thing out. I'm going to edit this video in a minute, but sorry, we're going to delete that. Sorry, I missed one important step. That is actually working out the velocity. All right, so over here, so at least I've shown you how to do a graph. We'll have another practice in a minute. All right, so velocity in meters per second. We need to add that in. We haven't done that yet. Okay, so to do your velocity, so now we need, you need to have done your time and need to have done your change of displacement. So that one there, if we're doing it in meters per second. Okay, we need to do this one first, then we'll get our velocity time graph. All right, to get your velocity, press equals, click on the change of displacement, and then we're actually going to divide by the interval of time. We're not going to divide by the time series because we use that for the graph. But the interval of time we worked out to be was 0.04. So basically all those changes of displacement in meters are going to be divided by 0.04. So that row slash 0.04 will give you the speed between those two dots. Okay. Then you can click that one and drag that command. And we have an increasing time. Yep, I'll zoom in on that one. Okay. All right. So do you want me to show you that again? I'll do it one more time. Okay. So go to the top one, equals, change the displacement. Now, divide by the interval of time that we decided was going to be for this one, which is 0.04. And you've got that speed in meters per second. Click on this and drag. And you've got that repeats the command for all the other rows as well. So if you click on these elements, it will show you what you've done. So you've divided that one by 0.04. Over here, you divided that value by 0.04. Okay, so that is actually our speed in meters per second. So let's get this right. So now we're going to do the velocity time graph. All right, so highlight the time and highlight the speed. Okay, then we go to insert. So I'm going to shrink this down to be able to do this, as I found before. Okay, then go to insert, chart, go down to chart, go to chart types, go down to a scatter plot. Okay. Okay, insert this chart. All right, so now we actually have a velocity time graph. I'll come by and help people in a minute. I'll just finish up what I'm doing here. I'll come by and at least help everyone get a velocity time graph going, and then we can work on the rest. Okay, so all right, so first thing I'm going to do, I'm going to put a chart title. I'll show you how to do that again. If you just click, if you right click on your graph and go into title, we'll give it a title. So that would be velocity. Actually, I might call it falling. Distinguish it from the other one. Falling ball velocity time graph. Or velocity versus time graph. Okay. All right, we should also give it, so going to axis, we're going to give it a horizontal axis title, which is going to be time in seconds. Okay. Oops, I lost it. You got to press enter. So time, bracket, seconds, enter to apply. There we go. So we've got time. If we go to the other one, axis, left vertical axis title. Okay, then we'll go into, so this is, now for this one we've got, this is going to be speed of velocity, speed in meters per second. Okay. Actually, I've called it velocity in title. I'm going to call it velocity here. We're only moving one way, so the terms are interchangeable. Okay, so, all right, now the other thing I want to do is I want to work out the acceleration. So this is the goal of what we're actually doing here. So I'll get you to do a few other graphs of some of the other motions, bless you. All right, but the main focus of here, what I'm recording this for, is actually to work out acceleration. Now, from what we've studied so far, so I put a hypothesis on the board, so hopefully you've been thinking about it. What do we expect the acceleration to be? The same as what? As other things, other falling objects? So what did we say that number was? You remember? In our course, we're going to say it's about 10 meters per second squared. Now, do we expect that the tennis ball will actually have the 10 meters per second squared of acceleration? Is it going to fall like what we saw in the video with the evacuated chamber? What might get in its way? It might. It's going to? Let's find out. Okay, so what I'm going to do now is I'm going to add a... Okay, so sorry. Remember how to do this? Okay, so you click on this little thing here, quick edit mode. Okay, not that one. Sorry, let's have a look at this. Legend, arrow title, okay. All right, I want to add a trend line. Okay, where we got trend lines? Trend lines. I have done this before. I've only done it once. Okay, for okay, there we go. Sorry, I got to click on that and bring that up. All right. So what I did there to bring up this option was I clicked on okay, click on the data. All right. So do that again. Okay, if I click on the data, sorry, left click on the data, I can add what we call here a trend line. All right. So I'm going to go and I'm going to add a linear trend line. All right. All right. Then I'm going to click on that trend line. All right, trend lines. So there I've got the option now, trend line 0. Okay. All right, I'll help people with the graphs in a moment. Sorry, just finish off what I'm doing here, then I'll turn the recorder off. Okay. Not quite. I'm having a few issues as well. All right, so a couple ways you could do this. You can actually work out the slope for yourself. You can actually go and work out the numbers. Now I'm trying to lost the. Let's have a look at R squared. So R squared. Okay, it's not quite as straightforward. Okay. So I'm trying to bring up a slope, like it calculates a slope. But you can actually calculate a slope for yourself if you do a, if you put this through enough grid lines, you can actually work out a rise of a run. Just to save us a bit of time, I'll tell you what the slope was, because I've actually done the calculation myself. The slope of this line is actually not 10, as we expect it would be if it was free falling. Actually 7. Okay, so last lesson we went through the concept of forces. So what do you think is preventing the tennis ball from not achieving that 10 meters per second squared of acceleration? What's it moving through? Air. So you've got air resistance. The other thing you've got, using the ticket timer, it will actually pull through, there's some resistance, because basically what you have is a little needle coming down and poking it, which slows it down. That's probably got a lot of reason why you get so much random error when you actually just go from adjacent dots. So why it seems to be speeding up and slowing down, but in general speeding up. So yeah, in this case we've discovered that we did not achieve the 10 meters per second squared of acceleration. But okay.